Hello and welcome to my YouTube channel. In this video, we will be refining some 10 and 14K gold. The first step is calculation of inquartation with either silver or copper. I prefer silver or sterling silver. Here are my calculations. I didn't get it on camera, however, I used my torch to melt down some 14K and 16K gold. Added some sterling to make it 6K. This is the crucible I used. Got a little sooty. And here's the 6K gold. I covered the gold with about 175 milliliters of distilled water. Next thing, everybody knows what water looks like. To that, we will add roughly the same in nitric acid. The nitric acid will part or dissolve all the base metals, leaving behind just the gold. The reason for adding the sterling silver is to reduce the gold to 6 karat. This allows the acid to fully penetrate and dissolve all the base metals. Without inquartation, the gold would not allow the nitric acid to penetrate fully and clean the gold. As you can see, it's a bit chilly in the lab this morning, so reactions will be a little slow. This is the other half of the nitric to bring it up to a 1-to-1 ratio with distilled water. I always start small until I know how the reaction is going to go, then I add the other half. And as you can see, it really gets it going. To speed the reaction up, we will add heat and do a light boil or simmer until no more fumes can be seen. Then we will repeat the process until no more fumes are generated when you add or simmer the nitric acid. Once the fumes start to clear, we can pour off the copper nitrate into our sterling jar. It will consume any remaining acid. After a few rinses to clear any remaining copper nitrate, the blue solution, we can reset for a second boil with a 1-to-1 ratio of distilled water and nitric acid. This will be our second nitric boil. Each time we boil the gold, the solution will get lighter and lighter. This is an indication as to how far along we are. We need to keep going until the solution stays clear, even under a boil. The solution has stopped producing fumes, so we can pour off and reset for the third nitric boil. Here is a look at the gold thus far. Same as before, 1-to-1 ratio, distilled water and nitric acid. A little stir. And now back on the heat. This has been boiling now for 30 minutes. Going to back it off the heat and pour off the nitric into the used nitric bottle. I generally save the last boil for the first boil on the next refining. After allowing some time for it to cool, I pour it off into the used nitric container. The solution is crystal clear. I think we can safely assume that all the copper and base metals are pulled out of solution. We can proceed to the next step. Now that we have this poured off and saved, I'm going to rearrange my workspace so that we can dissolve the gold with Aqua regia. Our gold at this point. The sterling silver jar will need to be removed and covered to prevent any contamination from the hydrochloric acid. To make Aqua regia, I use a process called incremental nitric dosing. It allows me to use minimal nitric to dissolve the gold. It also means that I'll need to use minimal denoxing before dropping the gold with S&B. And a touch of sulfuric acid to drop out any lead in solution. For cool points, you can tell me if it drops out as sulfate or as sulfide. Comment down below. Typically, I use half an ml per 100 ml of hydrochloric acid. Normally at this point, you can take your expected yield in grams of gold and add roughly half of that in milliliters of nitric, and then incrementally dose with the nitric from there. However, in this reaction, I am attempting to measure that by incrementally dosing from the beginning until all the gold has dissolved to see how much nitric it takes to make it go into solution. You can see fumes being produced here. When fumes stop being produced, it's time to add more nitric. Second addition of nitric. This will be our third nitric dose. As you can see, it begins producing fumes right away. Just like before, when the fumes dissipate, we add another dose. This will be our fourth nitric dose. We're up to around 15 milliliters at this point. Our expected yield is around 18 grams, so we should be getting pretty close, maybe 2 more doses. And dose number 5. Each dose has been around 3 to 4 milliliters. Dose number 6. Another indication it's time for another dose is the bright yellow fizzing action will stop, leaving only a boil. Dose number 7. "21 milliliters total, and I most likely have some excess nitric. Evaporation is my preferred method to get rid of the excess, and for that we're going to boil it down. After allowing some time to cool, I add distilled water ice cubes. This further cools the solution and precipitates out any silver as silver chloride. Anything that precipitates out will get filtered in the next step. Medium flow filter. We'll run this through the same filter twice to catch even smaller contaminants. And we'll change our flask out. The second pass through the filter really clears it up. Checking for clarity, I can read through it. Now we'll change our beaker and get ready to drop the gold with SMB. But first we're going to test with stannous chloride. A black stain will indicate gold in solution. I'd say it's positive. Once the gold is precipitated with SMB and allowed to settle for 24 hours, we can decant and rinse. Pour slowly so we pour off as little of the gold as possible. Trace amounts will get poured off, however we can recover that later. Now that we've got it decanted, let's transfer it into a smaller beaker for easier handling. This is distilled water. This is our first rinse with distilled water. I pour off into a beaker first before I go into my waste container. This catches most of what might pour over. It also affords me the ability to put it back into my original beaker before it goes into my waste container. I'll rearrange so you can see the process more clearly. We'll also call this the first rinse, even though I know it's like the second. This will be 6 rinses in 15 seconds. Now we can recover what would have poured off and move on to the hydrochloric acid boil. Boiling in hydrochloric acid really helps clean the gold. This will be boiling for 30 minutes. Once allowed to cool, we can pour it off into our recovery beaker. And our recovery beaker into our waste container. Now we'll do a few more rinses to get any remaining hydrochloric acid off. Rinse number 1. Two, 3. Empty the gold recovery beaker. 4. 5. 6. 7. Something that I have not shown yet is that before I pour off, I missed to break the water surface tension so that any floaters will settle out. For some reason, the cleaner it gets, the more it wants to float. And again, anything that gets poured over into our gold recovery flask, we can recover later. Now to get our gold sponge out so we can dry it. The less water you use, the less you have to take out. Distilled water mist to break the surface tension. The lavas run off well water, so all the water used is distilled. Now to remove as much of the bulk water as possible. Now that the bulk water is removed, we can proceed to drying it out with the oven. You can go straight to the crucible from here. However, if you want to keep it as a gold sponge, you have to dry it out. A toaster oven will work just as well. However, I happen to have a full-size spare. Safety disclaimer, don't use the one you cook with. This is after an hour at 130 degrees Fahrenheit, or 54°C. We'll give it another hour. And this is after 2 hours total. You have to be careful with it at this point. It slides around real easy. It's a very fine powder. Now let's go melt a small bar. Introductions. And our gold, single refining. These torches are going to get a little hard to talk over, and I'm wearing a respirator, so from here, I'm going to let you guys enjoy the sounds of the melt station. here's our bar. The one on the right is the bit that I thought wasn't going to fit in the mold, so I poured it out separately. It's a small bar, but it's got nice pour lines. And a mirror finish. I have always liked the pattern on the back the graphite molds make. Not really that bad for a single refining. I'll probably throw it in with my next batch, just so it can at least be double refined. Man, that thing is hard to stop looking at. Let's get a weight on it now. Per my calculations, we should get a yield of about 18.7 grams. One gram, off by 1 gram. That's not bad, not bad at all. Considering it's probably in my waste containers, and we can recover that later. I'd like to thank you all for watching. I really appreciate it.